Here we are at example 2e from our 4.3, 4.47 notes. We're asked to factor the following. Now, just looking at this, we end up with 27x squared minus 3. And because we just have two terms, they're recognizing it to be a binomial, because again, two terms. Our kind of first instinct when we're talking about factoring goes to possibly the difference of two squares. However, when we look at our numbers, 27 is not a perfect square. X squared is, but 27 is not. Likewise, 3 is not a perfect square. However, we always resort to step 1 when we're talking about factoring. And step 1, as we've spoken about in the past, is what is the greatest common factor? That is huge, and it will always make your life a little bit easier. I should say actually a lot easier when done first. Now, the greatest common factor, just looking at the two numbers here, 27 and 3, do they have anything in common? And actually, yes, they do. We can pull out that common factor of 3. Because 27 divided by 3 would then give us 9. And the x squared is along for the ride, because really when you factored out the 3, you just kind of factored it out from the 27. Now for the number 3, if you pull out a 3 and factor it, we should end up seeing the 1 there. And obviously the negative just kind of carries down as well. The negative you could also consider it as part of the 3, and so you're factoring out 3 from negative 3, and that's why you end up with a negative 1. So up until this point, we've really just factored out a common factor of 3, and now we're ending up with 3 times the quantity, 9x squared minus 1. Now at this point, some of us might be able to say, oh wait a sec, now we kind of have possibly some difference of two perfect squares. Now the difference of two perfect squares looks like a squared minus b squared, where we see this first term being a perfect square and the second term being a perfect square. And how that breaks down to is, according to our definition, a plus b times a minus b. So now the challenge just really becomes, if this is in fact the difference of two perfect squares, well, what are a and what are b? Our a value is again coming just from this first piece, or really just this 9x squared. So if we have 9x squared, and according to the definition, when it's factored, we have to think about a would be what, when we square it, gives us that item being squared, so this piece right here. So in other words, what squared gives us that 9x squared? What would do that? Well, when we just look at the number 9, we know that if we took 3 and squared it, we should get 9. Okay? Also, when we take the variable x and square it, we should get our x squared. So recapping one more time, to figure out the a value, which we don't know, but we do know that a squared was 9x squared. If we took 3, squared it, we get 9. If we took x squared, if we took x and squared it, we get our x squared. By doing that, what we've done is essentially identified, hey, this is what a is. Similarly, looking at taking the number 1, and when we square it, we end up with our b squared, which, according to this, is just 1. 1 is the only number that will be able to do that. 1 squared gives us still 1. And by doing that, what you've done is you've found out your b value. The other short trick is just pretty much just taking the square root of these each. And then there's your a, and then there's your b. So whichever method you would prefer, go for it. As long as you identify, hey, this is our a and this is our b. Now, the 3 is still out in front. It hasn't disappeared at all. It's still there. But we have identified our a and our b. It's just 3x plus our b, which is 1, and then our a, which is 3x, and then minus the b, minus 1. A lot of students, they'll just think, oh, as long as I find out the a and the b, I know one's positive, one's negative, and then they're done. So then this would be the most factored we can get. Again, though, that is example 2E from our 4.3, 4.4 set of notes.